Good morning to everyone. This is Saravanan. Now we have to see the topic of resolution in knowledge representation. So I hope you know well what is the expert system is, and this should be having an domain knowledge. So we have to making an expert system according to a particular domain. So that expert system is need of a knowledge for answering the users' questions. So here the knowledge feeding, it should be in need of knowledge representations. Okay, so knowledge representation is play a major role in the artificial intelligent expert system making. So in this particular knowledge representation is should be having concepts like a propositional logic and predicate logic. So both are very useful for representing the knowledge. So under this predicate logic, so resolution is play a major role. So this should be useful for converting our well-formed formula into a class form. So when we are converting a English statement into a well-formed formula, so it is very necessary to convert that well-formed formula into a class form, because that should be very helpful for knowledge representations. So now we have to see the concept of resolution. So how it is useful for convert the well-formed formula into a class form. So I would like to share my screen to show you the concept of resolution. Yeah. So I hope you see it clear. So resolution is play a major role in the knowledge representation. Why? Because this is such a procedure which gain its efficiency from the fact that it operate on the statement that have been converted to a very convenient standard form of knowledge. So when we are getting that convenient standard form of knowledge statement, that should be feed into an expert system as a knowledge. So this resolution is a very excellent concept in knowledge representation. This resolution, it should be having different types of steps for converting the well-formed formula into an class form. So is a concept convert to class form is coming under the resolution. So here we are going to convert the well-formed formula, that is the first order logic, into a class form with a sequence of 9 steps. So we have to take a example like all Roman who know Marcus, they either hate Caesar or they think that anyone who hate anyone is crazy. So is a English statement as we have to take that should be converted into a first order logical statement. So it's like for all x is a Roman and x no Marcus, it implies x hates Caesar, or for all y and sub z, y hate z implies x think crazy of y. So is a well-formed formula is equivalent to the English statement, which is all Romans who know Marcus either hate Caesar or think that anyone who hate anyone is crazy. So now we have to use this resolution steps to convert this well-formed formula into a class form. So for the above, we are having a 9 different types of steps. So in the first step we are going to take in is eliminate the implication. So under this particular convert to class form algorithm, so the first step is eliminate the implication. So here we are going to use the concepts like A implication of B is equivalent to negation A or B. So is a concept is a short form of statement conversions, so that we have to apply into a well-formed formula, our well-formed formula. So that should be going to become like for all x negation of x is Roman or and x no Marcus, or x hates Caesar, or for all y negation of some z, y hate z, or x think crazy y. So after eliminating our implication statement, that well-formed formula is changed into the following way. So our next step into the above process is reduce the scope of each negation into a single term. So here, according to the De Morgan's law, we are going to change the concept. So that is, we are going to move the negation inside of the parenthesis, that the statement which is available inside of the parenthesis is going to become like a negation b equal to p. That is, when negation is moved into the inside of the parenthesis, the inside statement is going to become negation. If it is already negation, means it became positive. So like in this above, so negation of A and B is equal to negation of A or negation of B. So it become like in this. So according to this particular De Morgan's law way, we are going to change our statement. So for all x, Roman x, negation of Roman x, or negation x no Marcus, or x hate Caesar, or for all y and for all z, because negation moved inside. So some existential quantifier is become an universal quantifier. So for all z, y not hate z, or x is think crazy of y. So our statement finally is changed like in this manner. So after completion of the second step, we are moving into a third step, which is nothing but standardize the variable, so that each quantifier it find a unique variable. So in that case, we have to assign a unique variable to each and every statements, or each and every class of statements. So our statement is available like for all x and p of x, or for all y q of x. It's available like means we have to make each variable as an unique variable. So finally, we are going to get the statements like for all x p of x, or for all y q of y. So instead of q of x, we are changed the variable into q of y. So here the variable is just a dummy name. So make change of the variable name, it not going to affect the truth value of the statement. So we are moving to a next step, which is nothing but move all the quantifier to the left side. So suppose our quantifiers are available inside of the statement also, we are moved into the left side of the particular statement. So finally, we are going to get that quantifiers like for all x, for all y, and for all z. Here, for all y and for all z is available inside of the statement, but after the fourth step, we are move all the quantifier into the left side. So it became like in this above manner. So at this point, the formula is in what is known as prefix normal form. So it consists of prefix of quantifier followed by the matrix. So which is a quantifier free. So that's why it is called like a prefix normal form. So after completion of our fourth step, we are into a fifth step, which is nothing but eliminate the existential quantifiers. So we have, if suppose we are having an existential quantifier, means that as we have to eliminate. So elimination of this existential quantifier, it affected the variable location. So in this particular existential quantifier variable location, we are going to add a new function, which is nothing but a scalar function. See, for example, that is existential quantifier of y is president of y. So x is the president. So some x is a president, like the statement is available. So that's we are going to write like a some y x y is y of president like. So we are going to eliminate that existential quantifier of y. So automatically the variable y is going to remove. So in this president of location, we are going to add a new function s1. That s1 is called a scalar function. So in single variable location, so we are going to see how to make change. Suppose we are having a double variable in the function parameter location, means so how we have to manage it, that we have to see. Suppose for all x and some y, y is the father of x. So we have to write the statement like. So here we are going to eliminate the existential quantifier some y, means so that y variable is going to get removed. So in this particular location, we have to use the scalar function like S2 of X. So this S2 of X is the scalar function. It's going to fulfill the variable location of Y. It's not going to make any change in the truth value of the statement. So this is what result of elimination of existential quantifier step. So after completion of this particular fifth step, we are into an sixth step. That is, we are going to drop the prefix values because we are eliminated all the existential quantifier variables, and instead of that, we are make the scalar functions. So now we are have only the universal quantifiers with corresponding variable. So now we have to remove the prefix of this particular statement. So automatically that universal quantifier prefix are automatically removed, and whatever variable available in the particular statement, those are is nothing but universal quantifier variables only. So we just have to remove the prefix of the statement. So the next step we are going to reach the seventh step is a convert the matrix into conjunction of digit format. So we are going to making the statements like a conjunction of digit format, like A and B or C is going to become like A or C and B or C. It's like, so it's like an associative property, like a distributive law, like a statement. So this is what conjunction of digit format like statements. So in that way, we are going to write our well-formed formula statement after this particular sixth step resultant statement is going to write like a conjunction of digit format like. So after completion of seventh step, we are into an eighth step is like a create a separate class correspond to the each conjunct. So we are making our statement like a conjunction of digit. So according to the conjunction, so we have to separate each and every as in separate classes. So now we are having a different types of multiple classes of a statement. So this is what our final result of that eighth step. So we have to use it into next step, which is nothing but the last and ninth step, which is nothing but standardize upon the variables in the set of classes generated. So we are generated a new classes of statement. So for that generated classes of statement, we have to feed new variables to make it as a separate one. So by this, we mean renaming the variable so that no two classes make a reference to the same variable. So we have to standardize the variables too. So for all x, p of x and q of x is going to become like a for all x, p of x and for all x, q of x. So we have to separate this statements or the classes. So this is an class form of a statement we are finally gathered from our well-formed formula. So like in the above, we are going to get our well-formed formula statement into different types of classes. So this is and not only the class, so this is a knowledge for the export system. So in that way, we are trying to reduce our well-formed formula into an separate classes so that each and every classes are in simple statement. It's complete a simple statement truth values are combined to get an actual truth value of the original statements. So it give an excellent result, and this is an now nice knowledge for feed into an expert system. So I hope you understand what are the 9 steps which is coming to arise in the resolution concept of knowledge representation, and how to convert the well-formed formula into a class type formula or class type statement. So that class type statement is an knowledge for feeding into an expert system. So I hope you understand. So thank you. We have to see some other concept in next video.